reciprocal quadratic functions. This is a different type of rational graph, one that you haven't seen before. What function results in this shape right here? I'm going to just circle it. So it's a rational function, and it looks like this. And has two VAs. Oh, no. It has two VAs. So on the bottom, it's going to be a difference of squares, or it's going to factor out into two VAs. Because for a VA, you solve for x with the denominator, and it's going to be two VAs instead of one, and it's going to look like this. And let's get started. So just solve for x with the Remember a cheat sheet from the previous video of rational functions? If you haven't watched the rational functions, okay, I'll give you a minute to write all of this down. Please pause the video and write it down. Okay, there you go. Let's get started. Okay, let's get started. Let's graph. Okay, so we have our graph here, and let's do end behavior. So as it goes to negative infinity, I see here that it goes, it approaches 0 from above the x-axis, so it's going to be a 0 plus. And as it goes into infinity, I see the same thing happening here. It approaches 0 from above the HA, from above the x-axis, so it's going to be also a 0 plus. Okay, and let's do asymptote behavior. So its asymptotes behavior is going to get a bit longer because we have 2 VAs, and it's the behavior around the VA that we're looking for. So let's use our handy dandy lightsaber tool. As it approaches -3 from before the VA right here, as it approaches -3 before the VA, I see it going to positive infinity. So the y value is going to positive infinity as it approaches the VA from the left. So y approaches infinity. So as it approaches the VA from after the VA, I see it going down, so it's going to be negative infinity. So as it approaches the VA from before, I also see it going down, so it's going to be negative infinity. And as it approaches the VA from after the VA, it's going up, so it's going to be positive infinity. So there's our asymptote behavior and our end behavior for the graph that we just created. And then I have a chart. So this one, we're just going to check extra points just to make sure that everything is in the right place. We're going to use a -1 and 1. So -1 and 1. Okay, so there are 2 extra points that we are accounted for. It's just to check for the accuracy of the graph. And there you go. So that's graph is completely finished. I'll give you a moment to go ahead and copy anything down that you missed, or if I'm going too fast for you. So I'll give you a moment there. Moving on. Okay. So this one, it's not going to be the 2 same VAs. We're going to have to factor this. X and X. I'm thinking -5 and +3. Because minus 5x plus 3x is -2x, and results in the middle term, and then -5 times +3 is -15. So there's its factor right there. So I have x equals 5 and -3. So those are, we solved for x with the denominator, and now we're going to go into HA. It's case number 1, so that means our HA is y equals 0. It's just a 1 on top, so there's no x-intercepts. And then for the y-intercept, I think it's -1 over 15, I think. And I'm right. So for the range, I didn't explain this before, because it is a point, the vertex for the when I'll show you here, so we have our VAs, we have these. So for the parabola that's under here as a vertex, so it is less than or equal to the y coordinate and it is greater than but not equal to 0. And it's because it has a horizontal asymptote of y equals 0. Because it has that horizontal asymptote, it is never going to touch 0. So that's why it's greater than but not equal to 0. And it's equal to or less than -1 or 15 because this parabola goes down. So I'll give you a moment to write that down. You can go ahead and pause. Get out our calculator. So it's 1 and -1 over 16. Okay, so if you're a little unclear on end behavior and asymptote behavior, I strongly recommend watching my previous videos about end behavior and asymptote behavior. It's graphing rational functions. It shows you the cheat sheets on how to calculate the VA, the HA, the x-intercept, the y-intercept. It talks about the asymptotes. It also covers the domain and range, and right now and then it covered something new, end behavior and asymptote behavior, that I strongly recommend learning. I can explain it the best I can in this video, but if you are new to it, then I strongly recommend watching the last video, just so you have a good understanding of what end behavior and asymptote behavior is. I explain more how to calculate or analyze for the end behavior and asymptote behavior, but then again, it would work better if you had a thorough understanding of it. So we have it graphed here. I made sure to do the vertex and then the y-intercept. I'm sorry if it's not closer to the x-axis. I'm trying to graph the best that I can. But let's move on to end behavior and asymptote behavior. So as x approaches negative infinity, I see y approaching 0 from above, which means it's going to be 0 with a positive sign. So y approaches 0 with a positive sign. And as it approaches infinity, I also see it approaching 0 from above the HA or above the x-axis. So it's going to have a little positive symbol to indicate that. If it was reversed, if it was coming from under, then it would be a negative symbol from the HA or the x-axis, whatever you want to call it. Okay, so I just did the asymptote behavior quickly here, but let me explain. As x approaches -3 from before the VA, I see it's going to positive infinity, that y is leading towards positive infinity. So I'm going to say y goes to positive infinity. As I see it approaching after the VA, I see that y is approaching negative infinity. So I'm going to write negative infinity for as x approaches -3 plus y is approaching negative infinity. And then we go over here to the next VA, which is VA x equals 5. I see that it's also going down, so I'm going to assume that it's approaching negative infinity. And then up here, after the VA, it approaches positive infinity. It's going up. So I see that it's approaching positive infinity for after the VA. The plus sign is after for values more than. The negative sign is for values less than. And then we have our chart here, but I'm not sure we have enough space. And I don't see a chart on my lesson plan, so we're just gonna skip that. Okay, let's do the list one more time. Okay, we'll stop there. You get the idea of how to solve for the VA, the HA, the x-intercept, the y-intercept, the domain and ranges. And then the one thing that's new is calculating the vertex for the x value and the y value and the vertex that we'll see under here for the parabola. And then we're doing end behavior, asymptote behavior, and hopefully we'll have enough room for a couple points that we can double check for accuracy. But let's get started. Okay, let's get to graphing. So this one is going to be a skinnier parabola. Okay, so we have it graphed right just there. So as you can see, it's all graphed there. It's a bit of a skinnier parabola down here. And it's also upside down, so flipped. Okay, so let's go to end behavior and asymptote behavior. So as it approaches negative infinity, I see it's approaching 0 from the positive side. So y approach 0 from the positive side, and y approach 0 from the positive side. We've done this a few times. It's the same answer every time for this graph. So, as x approaches the VA from before, I see it's going up to positive infinity. As it approaches the VA after, I see it's going to negative infinity. For the next VA, I see it's approaching negative infinity for the values before. And then afterwards, it's approaching positive infinity for the values after. So it would be infinity, negative infinity, and positive infinity. Okay, and again, I don't see any points here, but we're just gonna let's do 2 and negative 2. We're gonna get the same answer. Okay, so we have our extra points accounted for, and it's just a check for the accuracy of the graph. So when it's 2, it would be 1/3. When it's negative 2, it's also 1/3. So thank you very much for watching. I believe that's everything here. I don't see anything else. So thank you very much for watching. That's graphing, that's reciprocal of quadratic functions. I hope you found this helpful, and please check out the graphing rational functions video if you haven't already and you need some more understanding about what to do, and the cheat sheet that I provided, and just everything you need for graphing rational functions. So thank you very much and have a great day, guys.